When you solve a quadratic equation by completing the square, you are indeed completing a square. In this lesson, I'm going to show you how. So let's say we have the following. We have x squared plus bx plus c, which is equal to 0. So if you look at this x squared, that reminds me of a square of side x. So we have x here and x here. So you can imagine x squared, this term here, as a square. Then we have bx. So bx looks more like a rectangle. I will draw it here. So this rectangle will have side here, which is x, and the side which is b. So what can we do with this rectangle? We can split it in half. Then we can take half of this rectangle, we can place it just here. So this will be x again. This will be b over 2. Then we can put another half of the rectangle here. Then we get again, we have x, and the other side is b over 2. So as you can see, if we put this square and the two rectangles together, we almost have a square with what? With the size of x plus b over 2. But we are missing something. We are missing something here. So what do we need to complete this square? We need a small square with what size? I'll draw it like that. This will be b over 2, b over 2. All right. So the area of this small square is b over 2 squared. So that means now, how can we complete the square? I'll rewrite the equation here. We have x squared plus bx plus what? If we want to complete the square, we need to add b over 2 squared plus c. But since we added a term, we also have to subtract it. So we have to say minus b over 2 squared. All right. But let's see what we can do at this point. This is still equal to 0. So let's see if we can recognize a perfect square within this expression. X squared, b over 2 squared, and bx, which is taken 2 times. So we have x squared plus bx plus b over 2 squared. But don't forget that we have something like this, a plus b squared, that's equal to what? A squared plus b squared plus 2 times a b. So can you recognize or see something similar within this expression? This is equal to x plus b over 2 squared plus c minus b over 2 squared, which is equal to 0. So at this point we have this part is constant, so we can bring it to the other side. So we have x plus b over 2 squared is equal to b over 2 squared minus c. So at this point I can take the square root on both sides, so that we get the following: x plus b over 2 is equal to square root of b over 2 squared minus c. So if this looks complicated, don't forget that these are all constants. So the last step, what do we have to do to find x? Now we simply have x here. So we get x is equal to square root of b over 2 squared minus c minus b over 2. So when you take the square root of this, you get plus minus the square root. So you get a plus and a minus here, minus b over 2. Alright, so this is a general method you can use to solve by completing the square. So one thing you should be careful about: usually your equations are not of the form of x squared plus bx plus c, but rather they are of the form ax squared plus bx plus c. So in this case, the first thing you have to do, you have to divide by a all terms. So this will cancel out and we divide it by itself. Here left with the same expression as above. You can just rename them if you want. Alright, so what I've shown is a method which is quite general.